Hello, good morning students, and welcome back once again to another video for the class 10th light chapter. And today we are doing numerical once again to solve the further cases of the concave and convex mirrors. So the numerical for today is an object of height 2 centimeters is placed at a distance of 5 centimeters from a concave mirror having focal length 10 centimeter. Concave mirror having focal length 10 centimeters. Find the image distance, image height, magnification and ultimately the nature of the image. So you are supposed to find the four things as always, and you have been given the respective values. The height also is given, the object distance is given and the focal length of the mirror is also given. And as always, like I say this, draw a rough ray diagram whether it is asked in the question or not. Because in the questions, in the examinations, you will be asked to draw the ray diagrams, so it is always better to draw a rough ray diagram so that you get the idea of how the image will be. Okay, so in this case we have the height as 2 centimeter. As always, draw a concave mirror because it is given. The distance of focal length or the focal length is given as 10 centimeters. So f over here I am writing 10 centimeters, and the object distance is given as 5 centimeters. So the object is somewhere over here exactly in the middle. So this much distance u is 5 centimeters. Object distance is 5 centimeters. Now as you can see that if the object is between focus and pole, that means it is the last case. The image will be virtual and erect. That means it will be behind the mirror. So it will be enlarged, virtual and erect. But of course we need to find that by solving the actual numerical. When we get all the values, we will prove that the image was actually virtual, that means behind the mirror, not a real image, and it will be enlarged, that means its height will be more, and therefore it will be magnified. Magnified means it will be enlarged image, not a diminished one. Okay? So first of all, in order to find the image distance, we need to use the mirror formula. And the mirror formula is given by 1 upon f is equal to 1 upon v plus 1 upon u. Now u has been given to you, that is u is 5 centimeters, and because it is on the left hand side, as always, you will be taking it as minus 5 centimeters. The focal length is given, that is 10 centimeters. Once again, because it is a concave mirror, the focal length is on the left hand side, and therefore you take the focal length also as negative 10 centimeters. This much is clear to you, students. Let's move forward and substitute the values. Okay? So 1 upon f, that is 1 upon minus 10, 1 upon v plus 1 upon minus 5. The negative values there in the denominator, you can take the whole number as negative as well. So minus 10 you can take as minus 1 upon 10, and because this is minus 5, you can take this as plus and minus gives you minus 1 upon 5. Now because you need to find the value of b, take the minus 1 upon 5 on the other side of the equal to sign, and therefore it will become plus 1 upon 5. Very simple. So this will become minus 1 upon 10 plus 1 upon 5 equals 1 upon v. Okay? Simple. 10 is the LCM. So you multiply 5 by 2 and over here 1 by 2 as well. So what you get is minus 1 plus 1 2 is 2 upon 10 is equal to 1 upon v. Okay? Therefore I can write 1 upon v is equal to plus 2 is, I can write 2 minus 1 because minus 1 plus 2 or 2 minus 1 upon 10. Therefore 1 upon v is 1 upon 10. 1 upon 10. Now when I take the reciprocal of this, I have to take the reciprocal of this as well. Therefore v is equal to 10, and because there is no negative sign, it means it is plus 10 centimeters. So like I said, because this is the last case when the object is between focal length, focus point and pole, at that time the image will be behind the mirror, and because this plus sign indicates that it is on the right hand side of the mirror, which means it is virtual image. Okay? You have found the image distance. So the first part part of the numerical is done. Second part, finding the image height. Okay, so to find the image height, you have the formula magnification m is equal to h dash upon h. But for that you will require magnification. And to find the magnification, we have one more formula as well, that is minus v upon u. So first of all, you will need to find the magnification. It is not always necessary that you have to solve the numerical in the given order. You can find the magnification first. It's fine totally. Okay. So finding the magnification, m is equal to minus 1 upon u minus v is plus 10 centimeter. So I am writing plus 10 centimeter. Okay. And u is minus 5. Minus 5. So minus and minus sign gets cancelled. So what you have over here is 10 upon 5. So you can write 5 2s are 10 and this gives you 2. So the magnification is 2, which is greater than 1, and therefore the image is enlarged. Image is enlarged. Okay? Image is enlarged. And plus 2, I can write over here plus 2 indicates image is erect. Image is erect. Okay, that means it is not inverted, it is the same as the object, it is standing upright, not inverted. So now you have the magnification and the image is enlarged as well. Now you can find the height. Therefore, magnification m is equal to h dash upon h, where magnification m is 2, h dash upon h is given as 2 centimeters is the height. So I am writing 2 over here. Simple cross multiplication, this gives you 2 into 2 equals h dash. Therefore, h dash is equal to 4 centimeters. Okay, so you have found the image height. Okay, now you have done 3 of the things, that is finding the image distance v, then you have find the magnification, this one 2, where is it? Yes, magnification is done, and the last one is finding the image height. The only thing now left is to write the conclusion, what kind of image it is. So for writing the nature of the image, so the last statement is really important. You are supposed to write each and everything about the image. You have to write the image is virtual and erect and enlarged behind the mirror. Okay, so you have to write like this: the image is virtual. Image is virtual and erect. Virtual and erect and enlarged. Okay. So the last statement you have to write in this way. I hope it is clear to you, students. So like I said, as always draw a rough ray diagram in order to find the perfect solution to this. Suppose you make a mistake anywhere over here, then you will get the wrong answer. If you get the wrong answer, you can refer to your ray diagram as always to verify the answer. If you get suppose v as minus 10 over here, suppose, then minus 10 indicates that it is on the left hand side, which is not possible, because if the object is between focus and pole, that means the image will always be virtual and behind the mirror. That means the answer has to be positive. If it is negative, that means you have done something wrong. Same thing over here. Suppose you get the 2, but you get minus 2 somewhere over here. Suppose, hypothetically, then if you have minus sign over here, which means that the image is inverted, and enlarged means beyond C. Beyond C we get the enlarged and inverted image. Once again, that is incorrect, because if the object is between focus and pole, you always get an enlarged image, that is correct. But it is virtual, that is behind the mirror. So you should always get this as positive for the last particular case, because it will be virtual and erect. Minus magnification means it will be inverted. But in this case, if it is above the principal axis, that means it should be positive, which in this case it is. Okay, you don't need to write this greater than 1. That was just for your explanation purpose. You just have to write magnification is 2. And remember, magnification does not have any units. So don't write 2 centimeters or anything else, because magnification is just a ratio. Okay, and ratio, that means centimeters upon centimeters, and the units cancel each other out, and therefore there is no, magnification is basically unitless. Okay, and when you're finding the height, that time you have to mention the unit, that is 4 centimeters. I hope it is clear to you, students. Okay students, time for the ray diagrams. So the numerical that we just did was actually a long numerical, and this type of questions are asked in the examinations for 5 marks. But in that, one more thing is added. You have to draw the ray diagram, and that too an accurate one. Okay, so let's say that you have to draw an accurate ray diagram which will be mentioned in the question. If it is not mentioned, still you need to draw a neat and clean diagram. So let's say that you have been asked to draw an accurate ray diagram using the values. Okay, so like I said, first of all, if you have done enough practice, then drawing a rough ray diagram is not an issue, like I just did. Okay, so after solving the numerical or before the numerical, you know that what will happen. This is f over here, object is over here, image is over here. So you have 10 centimeters, and 5 centimeters. So overall, you will require 20 centimeters on your page, and everything will be done in between. So first of all, draw a long line, and in between mark 2 points, that is 20 centimeters. So first of all over here, and second one over here. Let's say that this much distance is 20 centimeters. This is to make your time much more easier. Okay, so this everything will be done in between. But now don't start drawing the image and the object. Start with the mirror first. So let's say that this is 10 centimeters. That means you will have somewhere over here. This is 10 centimeters. Now you can remove the older bracket so as to remove the confusion. 10 centimeters. This is focus point. Your point of focus. Okay. No need for the radius of curvature. It's fine. Unless you are drawing a ray diagram where the image is beyond C, like in the previous video that we did. Okay, if the object is on the C and the image is also on C, at that time you will have to require the center of curvature. But in that case, you will not require this part, that is on the right hand side. So you can shift the mirror on this side. So let's say that at this particular point you have your concave mirror like this, focus point over here. Correct? And because your object is at 5 centimeters, mark a 5 centimeter point on this line, and because the height is also given as 2 centimeters, use your scale and draw a 2 centimeter height object over here. Right? Edge is equal to 2 centimeters. Okay? This is your pole. And now for the image, because it is at 10 centimeters, you already know, you have measured this. Write V as plus 10 centimeter over here. Write U as minus 5 centimeters. You don't need to draw brackets. This is just for your knowledge purpose. Okay? Otherwise, it is only going to make your ray diagram more and more confusing. Okay? So I will remove the brackets over here, just so that you can clearly understand the image. Now for the image, which is of the height 4 centimeter. So over here, measure 4 centimeters. Okay, little bit more. 4 centimeters. Okay. Now the things that we studied in the very beginning of the chapter, that is drawing 2 rays from one particular point, which is enough to draw the ray diagrams. First, take a parallel ray of light. If you take parallel, then it will pass through focus. So if you take parallel, then the ray of light will pass through focus like this. So the parallel ray of light goes towards the mirror. After striking the mirror, it reflects back and passes through focus like this. Point of focus. So the ray of light moves in this direction. Okay. The second one is, you can either take through center of curvature, but because center of curvature is very far away, you can go through pole. So take the second ray of light like this. Okay. But from this point, you have to take angle of incidence and angle of reflection. No need to waste time on that. Okay. Just draw a ray diagram like this. Because you are drawing everything accurately, your angles will be same as it is. Just draw the ray like this. Take the virtual ray behind and this one as well. Take this ray of light. They will meet over here at this particular point. Okay? Focal length minus 10 centimeters. So the ray of light goes like this and it bounces back from the mirror on the pole, and when you take the virtual line like this, they will meet at this point, and at this point is where your image is formed. So this is how you are supposed to draw the ray diagram, students, and we will check the other cases and other numericals as well. Till then, have a nice day.